Whoop, there's the question. I'm going to write some electron configurations for cations and anions. All right, strontium is a group 2 element, so it's going to have 2 valence electrons. It's going to want to lose both of them to form its most stable ion, and therefore it's going to be a 2 positive cation. All right, here it is. So let's just use noble gas notation. By losing 2 of its 38, it's going to be isoelectronic with krypton. That's called the octet rule. So the noble gas before number 36 is argon. And then we're going to pick it up from here, the 4s block, 4s2, 3d10, and 4p6. Next up, cesium is a group 1 metal. So group 1 metals have 1 valence electron. It's going to want to lose that to become isoelectronic with its nearest noble gas. All right, cesium's way down here. It's going to lose 1 of its 55 electrons to have the same electron configuration as xenon. So the noble gas before xenon is krypton. So we're going to pick it up from here, the 5s, 4d, 5p6. All right, on to indium. Got a little different one now. So indium has 1 electron in its valence p. Let me use something darker. In its valence p subshell, and by losing that, it's going to have all the subshells full. So indium is going to lose 1 electron, become 1 positive. The noble gas before number 48, because it had 49 electrons, and losing 1 is 48. The noble gas before that is krypton. So we'll pick it up here from the 5s block, 5s2, 4d10. All right, lead, similar situation with lead. What color can I? Let's go purple. All right, it's got 2 electrons in its valence p, in its final p orbital. By losing those 2 electrons, all its sublevels will be full. Let's do it down here. By losing 2 electrons, it becomes a 2 positive cation. The noble gas before lead, or in this case, number 80, or 80 electrons, is xenon. So we'll pick it up from here, because xenon is number 54. That covers 54 of the electrons, and we're going to try to get up to 80. So 6s2. All right, now you gotta go down here to the 4f block now. Follow alpha. 4f is going to fill with 14 electrons, and then we're back up here, 5d10. Back to now we're on to the anions. All right, kind of running out of colors here. Well, this is good. The phosphide and sulfide anions are going to have the same electron configurations, because when sulfur gains 2 electrons to become sulfide, it's going to have 18 electrons. And when phosphorus, which has 15, gains 3 electrons, it's also going to have 18. So phosphide and sulfide are going to be isoelectronic with argon. So the noble gas before number 18 is neon. And we'll just pick it up from here from the 3s, 2, 3, p6. And finally, let's go to bromine or bromide. Right there, 7 valence electrons. Those halogens have. It's going to want to gain 1 more. That's why it's a 1 negative anion. By gaining 1, it'll be isoelectronic with number 36, krypton. Let's go to the previous noble gas. That's argon. And we're going to pick it up from the 4s section, 4s2, 3d10, 4p6.